Okay, so this is a camera slider that I designed in SolidWorks and that I'm working on. It has a stepper motor on this end, and this is just two pieces of copper, like plumbing tubing. I built this trolley with skateboard bearings that slides along here with these 3D printed wheels. And it's taken a lot of tries to get these wheels to be the exact right size, but they're close enough now to where I'm pretty confident. I just have a revision 2, looks like this, of the end on this side. So I'm going to swap it with this one right now, just because this version gives me some room to tighten. It has slots here, so I can tighten the belt a little bit easier, tension the belt. So I'm going to swap this guy out right now. Oh no. Damn it. It wasn't supposed to do that. Well, at least we know that holds pretty well. Okay, so I finally have everything finished that I need for this build. These are going to be my rails for the slider. So these are 2 copper tubes like you would use for plumbing. And then these are failed versions, but basically these are my end pieces. So it's going to be like this, and the copper tubes go in between. And then this is my, I'm calling it a trolley, with these wheels, and they're on skateboard bearings. And those ride along on the outside of the 2 tubes. So that's the mechanical side of things. Oh yeah, and then I'm going to have a belt with a little attachment bracket here, so that I can attach the belt onto the trolley so I can have movement. So for the motor, I'm using one of these NEMA 17 stepper motors. This guy's probably a little bit overpowered for what I'm doing, but it's whatever. Then for controlling the whole rig, I've got an Arduino and I've got a stepper motor driver, and so I'm going to be programming this to run the stepper motor. The stepper motor goes over here, in here like this. That's not going to stand up. And then to know when I've reached either end, I have these little clicky toggle limit switch guys that are going to be mounted on either one of these to know when I've reached the end, to sort of calibrate it, because this motor doesn't have position, doesn't know where it is, but it knows, you can tell it how far to go. So once it reaches the end of either side, and we know how many steps it takes, because it's a stepper motor, so it does like 200 steps per revolution. Once I know how many steps it takes to go the whole distance of the slider, if I want to go halfway across, I just do, total steps divided by 2 or divided by a quarter if I wanted to go a quarter of the way, and so on. So that's sort of how I'm going to keep track of where I am on the distance of the slider. It's basically just like a 1-axis CNC. This isn't anything new. This is something that has been around forever. My 3D printer, it's over there. It's just a 3-axis CNC. I'm just building a 1-axis CNC basically, but it's going to carry my camera. So let's get started. Well, it's not the smoothest rolling thing ever, but it's not too bad. Ooh. It's kind of rubbing. That's a lot of weight though. Well, it's gonna have that much weight on it, so. I think the trolley is gonna need modification, yeah. Here, I'll show you guys what's going on. So the way I designed this to ride was on the rails like this. The problem is this is putting a load like sideways, so when you put a lot of weight on it, it kind of rides in a little bit. It slips down and it rubs, and so I think I'm gonna have to modify my wheel design so that it can handle more weight. The reason I did it this way was just because if you ever want to flip it over or put it on its side or anything like that, which I don't think I would do very often, it's captive, it's not gonna fall off. I might end up changing that. So this is that cute little motor driver, stepper motor driver that I was talking about. So here's basically how it works. You have 8 pins on each side, 16 total, and here's what they all do laid out. It looks complicated, but it's not too bad. On this side, we have motor power positive and motor power negative, power and ground, and that's what's going to actually be powering the motor. So for us, we're just going to be using 12 volts. Then this is where the motor actually connects. So these 4 pins are the 2 coils in the motor, the A and B of each coil in the motor, and then this is the power, just to power the chip, just to power the circuitry on board. Then over here we have an enable for the whole chip. So if you pull this low, it enables the entire chip. These are 3 micro-stepping selection bits. Basically, you can put in a binary number, so like 0, 0, 0, you can do 0, 0, 1, 0, and that'll select between full steps, and you can do up to, I think it's 16th steps, so you can do more control over your motor, or smaller steps. This just resets the chip. It's a reset. Sleep, if you want to put it to sleep, it'll stop powering the motor, save some battery. And then these are the 2 that actually control the motor down here. So if you pulse the step pin, it'll go forward 1 step. So if you're in full stepping and you have a 200 steps per rotation motor like we have, you pulse that 200 times, the motor will do 1 revolution. And then this one is direction. And so if it's positive, the motor will do clockwise. If you have this negative or tied to ground, it'll go counterclockwise. That's how we control our motor. So that's what the Arduino is going to be managing, is all that. Started. Let's see if it moves in the appropriate direction. Oh yeah, look at this. Sick. Okay, it should move now. Y'all ready for this? I don't think y'all are ready for this. Hopefully it doesn't explode. Well, it's backwards though, but it's moving. Bro. Wow, it can move things. How cool. Then you click, and then it switches direction. It's this side? Nice. Okay, so I'm kind of scared because it's just gonna keep going if it doesn't trigger. Uh-oh. The moment of truth. Is it gonna line up? It better line up. Uh-oh. Oh goodness. Oh! Yes! And now I'm gonna go back the other way. And it'll click, and it'll just keep doing that forever. Nice. Cool. It's working. Okay. Well, I guess now it's all that's left to do is just to write a more interesting program for it to do. I'm actually going to take this off for this because this is going to make it really fast.
Goes. Oh. Wait, what?
Motor doesn't have enough power to go that fast. Okay, that's not going to work. So my old trolley design couldn't hold a lot of weight, and that was just because the wheels were mounted on the side, and so they didn't have a lot of area to really like put force on these rails. So I moved them into like a 45-degree angle onto the trolley. Now it can handle a lot of weight. And now I've moved on to try to make it do a program that's actually useful. Okay, so now I have it running. Whoa, that was whoa. Not supposed to do that. Okay, so now I have it running back to just doing some basic acceleration. So it's gonna home itself and then just go back and forth with some nice smooth acceleration. And I can control the speed of the acceleration. So you can see here, I can make it go pretty fast, or I can make it go pretty slow. It's still kind of noisy, and I can make it go faster for this next one. I think I need to soft mount this motor. I think the motor is just vibrating everything. But yeah, you can see that I can adjust the potentiometer and it controls how quickly it moves. Now you're gonna say, Gavin, so what? How are you gonna, you need a camera on it. You need to make this interesting. And that's where this comes in. So this is a DJI Osmo Mobile 3. And what I'm gonna do is I'm gonna plop this guy right on the middle of this. And then I'm gonna use active track and lock it onto an object. Maybe I'll use the water bottle. And as it moves back and forth, the gimbal will keep the object in frame. And so I can get some cool like tracking shots. Okay. Oh, I think I literally just go like this. Put a box around the camera. Whoa, that's pretty cool. Let's slow it down all the way. That's all the way fast. We don't want all the way fast. Yo, it's tracking the camera and keeping it in the middle of the frame. That's pretty cool. Oh my god, there's like a million uses for this. That's fun to watch. Oh, that's cool. Okay. I'm happy with how this is working so far.